Hello, everyone. I'm Chip. So, actually, I'm gonna give a new talk today. I came here today. It was just like, let's try. I just felt like when I talk to people, it's like this topic might be a better fit for you all. So I hope that I'm right. So we're talking about debugging AI applications. But first, obligatory company intro. So I'm working with Vonchon Data, and we build GPU native query engines. Basically, we focus on workloads that are too big and too expensive for Spark to handle. So the idea is that data processing is naturally parallelizable. So like if you want to process a billion rows, you can just farm them out to like thousands of GPU cores. So we're also involved with open source. So we are the core maintainer of two open source projects like IBIS and Arrow. I'm also the author of Designing Machine Systems, and I'm working on a new book on AI engineering. And as a part of doing research for my book, I go through like almost like every single AI tool that comes my way. And it's very painful because there are a lot of those. So to make my life easier, I only like look at those with at most 500 stars. So you can like look at all of them here on my website, and you can browse them. Like I manually categorize them by like what they do, and I also find it helpful to track like how many stars, like how fast is this growing, because I see a pattern which I call like the hype pattern. Like a repos comes out, it gets a lot of stars, and nobody ever uses this again. So like I think it's useful to see how things grow. Okay, so for also head analysis that you can check out. So I often hear a lot of questions. It's like, which model should I use? Should I fine tune or should I do RAG? Like how many examples that I should include? And I feel like the answer always depends on like what kind of issues you are trying to correct for the applications. So what you want to do next depends on what are the failure modes for the applications. So I categorize the failure modes into like 6 kind of failure modes. So one's like information based, behavior based, latency. And because we only have about 20 minutes today, so I'm gonna go over the first 3 types of failure modes and how to address them. So the first one is information based failures. I think the slides have changed and this does not. Oh, okay, so this is an older slide, but it's okay, it works. So I would say that like information-based failures is the vast majority of pain in a system today are caused by these issues. So it caused like, what does it look like? So it looks like when the outputs are like outdated. So for example, you ask the model something and the model says something like, as of my cutoff date, this has not happened yet. So you don't see that information. The other ways it happens, way more common, is hallucinations. So hallucinations, there are many reasons why a model hallucinates. But it's just like hallucination is just part of the model. Wait, can you hear me better? Because I heard there's some echoing issue with the room. Good. Okay. So hallucination is just part of the model of probabilistic natures. However, models are also more likely to hallucinate when it doesn't have access to the right information. So AI does have this bias, like bias toward actions. So even when it doesn't know, it still tries to respond and do something. So you can see that like when you ask the model of questions that involve some rare or niche information that is unlikely to appear in the training data, the model is more likely to hallucinate. So like this is a very common issue, like information-based failures. So I would say this like usually the first course of actions is to try to address this kind of failure. So you can do this by like enhanced context. So there are 2 ways you can go about it. First is you try to retrieve information using a retrieval system like in a RAG system. You can also give the model tools so that it can gather information itself. For example, using web search or other information. So so first like with retrieval, so usually think of like retrieval as doing unstructured retrieval, like you retrieve data like images or documentations. And retrieval is a very old science. It has been around for like many years. And retrieval is the backbone of like search, recommender system, log analysis. So many of those systems, like for search and recommendation systems, can be used for RAG. So in general, you could think of like they have like term-based retrieval, like keyword search, or like BM25, or fancier techniques like vector search, and also like hybrid search. But I would say that like if you want to start with something simple. Like BM25 is a lot simpler than a vector search, and it's very, very strong baseline to beat. You can also do retrieval from like tabular data, like a SQL table. However, doing retrieval with tabular data is a lot more, like it's a lot different, like retrieving documents, because you first need to convert the natural query into SQL queries. So you need like text to SQL queries, and then you need to get access to the SQL executor. So it's a bit trickier because now you need like models to like follow the SQL format, and then you need to put guardrail because you don't want the system to accidentally execute like some dangerous like SQL queries. Another thing to like retrieve like augment context is to use tools. So like one very, very common, I think like one of the first tool that people are very excited about with ChatGPT is like web search, browse the internet. So now you want to give it things like web search, news API, weather API, but there are other tools you can give model access to as well. For example, like calculator or like a bash terminal. And I think this is like, so some people call it like agentic workflows. And people think of like agent is like very fancy, but I think of like agent is just like, okay, you give it access to like tool API calls or like functions you can call. So I could put both action API and retrieval under like the category of like context constructions, and it could look something like this. So like the goal is just to give the model access to the relevant information so that it can produce better answers. So the second kind of, so you can see it's like actually really like this research of paper. So it just shows it compares like RAG versus fine-tune impact of those on different, like this is on the MMLU benchmark. And you can see that like RAG gives a really strong performance boost. Like it usually performs much better than fine-tuning, but at the same time, like sometimes it can even perform better than RAG plus fine-tuning. And retrieval is especially useful for use cases that involve new information. So for example, like here's a benchmark focused especially on current news, and you can see just like RAG is just like outperform fine-tune and even fine-tune plus RAG. So that is interesting because like why would base model plus RAG outperform fine-tune model plus RAG? So I do think that's like when you fine-tune a model, there's a chance that the model does better as a fine-tune task, but so its other capacities is just get impacted and not gonna perform just as well. I don't know. So when you do retrieval, one very common thing that you do is a query rewriting, or some people call it like query normalizations, or also like query expansions. Because sometimes in conversations, you would have the queries, it's like just don't quite make sense if you want to use them verbatim for like retrieval. So first of all, here's an example. You can ask, like user first ask, when was the last time John Doe bought something from us? And then the follow-up question is like, how about Emily Doe? So if you try to retrieve documents using how about Emily Doe, you get something very irrelevant. So you would try to rewrite the query into something like this. When was the last time Emily Doe bought something from us? So there are different ways to do query writing, but usually AI is pretty good at that. Like you can ask another model to say, hey, given all this context, I rewrite this question so that it make it easier, like to actually say what users are like, asking. However, query writing can be quite tricky. So let's say that user asks a question like, how about his wife? So now we need information like who would be his wife, right? So you need to be able to like do identity resolutions. And if the system does not have access to the information, it has to respond like, sorry, we don't know who John Doe's wife is, instead of making up some name, like hallucinate something. Okay, so the next type of failures is the behavior failures. So one way it looks like is that like when the outputs are factually correct, but are not quite what you want. So here is simple, right? Like user can ask like, hey, why is retrieval important for AI applications? And it responds like, retrieval is an important technique for search and recommended system. So this is correct, but it's not what users want. So another way this can fail is that like users don't follow the requested format. So a very common format that often requested by models is a JSON. So you want JSON with like valid JSON with certain keys. So you can just have like one, like here's an example. You can see that it output first as a preamble, like the answer is, which makes it not parsable for like a JSON parser. Or the JSON is just like invalid or like missing a closing bracket, or it just doesn't contain the keys that you want. So like these two are very common behavior-based failures. So the next question is that like, how do we address those? I feel like I used to take a course, so it's like I always want to wait for students to respond, and people don't respond. So one way is like to use like prompting, which is like just adding more examples, and I try to get like hoping that model was like be able to follow the examples. You can use like some validators, like JSON validators. You can use like AI to so validate. You can also like use post-processing. So LinkedIn recently has a pretty interesting case study. So they found out that the model by themselves can only output JSON correctly 90% of the time, but then also realized that when they fail, a lot of the errors following similar patterns. So they wrote a script to like manually correct those errors, and they were able to boost the correctness to about like 99%, which is enough for the applications. Another thing that is not added here because it's an older slide, which is just use a better model. So it has been shown that as model becomes more powerful, they also get better at following instructions and can output like more, and can output like format more correctly. And another thing you probably want to try, look into like constraint sampling, which I think is pretty interesting, but also like a bit harder to do. And a lot of time, because constraint sampling, like you have to like define a grammar to force a model to follow that. So why it's very interesting, I know that like math PhD loves that problem, but sometimes like the effort to spend on like defining grammar might as well be spent on doing fine tuning or like training a better model. So the last solution here is so fine tuning. So here's an example of what constraint, a very simple constraint sampling could look like, but because of the interest of time, we won't go into. So basically, you put it before like the sampling layers and try just like how you can sample from like those valid tokens instead of like on the tokens. And so one thing I want to find out is fine tuning. I put it as the last year. So fine tuning is never the first answer to anything. So fine tuning is the last line of defense. And the reason is that like fine tuning, not only it requires an upfront cost because you need like data, you need people know how to do it. It also requires continual maintenance. Like once you have the fine-tuned model, what do you do? Like how often do you want to fine-tune it? And what if there's another base model that comes out? Like how fast can you iterate compared to like how OpenAI, Gemini, Anthropic can iterate? So it's just a very big commitment to get into fine-tuning. So the last failure mode I want to get into this in this talk is latency. So like there are many different metrics for latency. So how should like solve latency depends on what metrics you care about. So here's some of them, like the first time to first token, right? After users send a query, how long until you see like the first token from the users? People care about like time between tokens, which is the newer latency metrics. People have found out that sometimes users get more frustrated when it's just like someone types so slowly, or like tokens per second, and also the total latency, like how long does the latency take in total. And this is especially important for when you use some kind of like chain of thought, or like you get model to do planning when the response might require multiple steps until it completes. So it can take like minutes, and it can be like quite scary. So you talk to a company and they said like, so let's ask a model to do chain of thought, and the quality is good, but then it takes like 3 or like sometimes like even like longer to complete a response, and it's just like unacceptable. So latency, like how do we deal with latency? So good thing is that like latency is not a new concept, right? Like ever since people have been having internet, we've been thinking about like how to get things faster and faster. So a lot of those latency solutions we can use for this. But there's also like newer solutions. For example, like streaming mode. When you use like OpenAI Anthropic, you do like, instead of like waiting for the whole response to complete, you can just show users one token at a time. However, it comes with a trade-off, which I think of as the security versus latency. So the reason is that like why it can get users to see the response faster, it also like make it harder to validate the response, because now you just show it to user before you can validate whether the response is safe or is good. Another is that using cache. So like they are manable like exact cache. This is a cache system. It's not new. I feel like everyone who deploys software know what a cache is. So you can use like AI to predict how long, like whether the query could be repeated again. So for example, like if the query is very unique, like how's the weather right now? There's no point caching it because it's gonna change the next minute. But however, if the query is more likely to like be appear again, then you might want to cache it. Another kind of cache I thought is very exciting is like prompt cache. Who here is familiar with prompt cache? So prompt cache is just like, it's a pretty new technique. So I think it's already incorporated into Gemini just like last week. So the idea is that when you have queries that have shared text segments, you can cache the text segments so you don't have to process those again. So it's very common when you have like system prompt or examples. Like, so a lot of the queries also have the same system prompts and examples, so you don't have to like process this again between queries. So for Gemini, I think when they announce the pricing, it's like for cache tokens, it's like a quarter of the price, but you have to pay extra like for cache storage, which also like make it a lot some cheaper. I also like mention something here like semantic cache because it comes up a lot. But honestly, if you think about semantic cache, I would say like think again because it's very easy to get it wrong. Like other cache system, right? Like it usually just makes you think faster and doesn't change the quality. But semantic cache can cause some model output to be wrong if you like get the wrong item. So just something to think about if you decide to go about semantic cache. Another way is like to try to decompose a task into a smaller task. So the idea is just like you can try to do as much as subtasks in parallel as possible. So first of all, you want a task that say, hey, rewrite this essay into 3 difficulty level. One for first grader, one for 8th grader, one for college student. Then you can do all 3 of these tasks at the same time. You can also like try to get simpler model for like smaller tasks, right? If this task is simpler, maybe you can use like a simple classifier or like a 7B model instead of like GPT-4. That would have speed up your task. You can also like use or like fine-tune a smaller model to like imitate the behavior of the large model, which give you model performance while also increase latency. But again, fine-tuning is tricky. And the last one is it's like a bit interesting. It's just like I've seen some companies when they have outputs that have high variance in latency, especially with chain of thought. Like one query might be very fast, but the next query might be very slow because it takes more steps. So they try to generate multiple outputs at the same time, and whichever completes first, they send it back to users. So here you have the latency versus cost trade-off. Because it can have reduced latency, but you have to do more query like API calls, which costs you more money. Okay, so I think like that is pretty much all of my time. I just want to like summarize. It's actually inspired by a slide from OpenAI. I should have put a link there. So basically, when you start, I think you should just try to make the most mileage out of like prompting, add examples, and then you try to do with simple RAG like BM25 or keyword search, and only after that like fine-tune is like much later because it's more complex. Yeah, so that's me. I have on Twitter, LinkedIn, Discord, and here's my blog when I write a lot about AI applications. Thank you very much.
All right, thank you so much, Chip. Before Chip leaves the stage, do we have any questions for Chip? We have just a couple of minutes. All right, you got some questions after all? All right, raise your hands one more time so I can see. All right.
What are you most excited about next?
I'm actually really excited about AI for storytelling. So I'm talking to a company recently, and so I think like storytelling. So I come from a writing background, and I think just like storytelling. If you know how to tell a good story, you can get people's attention. So you can have people understand technical concept better. You just like make things easier. So it's very common in like gaming. I'm talking to a company right now which is doing story generation for kids. So what they do is that they try to detect like what words that kids have trouble with, and they try to like generate stories with those words to encourage kids to learn the words more. And it's pretty interesting because like when you generate stories for kids, now you have a constraint generation problem because you can only use the words that the kids are familiar with, and that really limit the kind of stories you can create.
Hello, thank you for your presentation. I have a question. So does prompt cache help with the context window as well?
It does not, unfortunately. I don't think so.
Okay, okay.
All right.
Hey, I actually had a question about the performance part that you were talking about. You were talking about time to first token. I was just curious if you had any thoughts on how OpenAI is doing it with their 4.0 model, because some people have thought that it's possible that they're actually using a sort of human tweaking effect instead of speeding up the model by having the model always say a leading word like, okay, and then start giving you the answer or something like that. It usually has something in there that pauses long enough that even if their time to first token was drastically slowed down, the person using it would never notice. Is that a method that's being employed, or is this pure hypothetical?
I feel like if I knew what OpenAI is doing, I feel like there's a way you can arbitrage information. So I do think it's like, I hear online posts say that OpenAI is much better at hiding latency, and I think that there's certain techniques you can use to hide it. Some idea came up recently, I didn't come up with it, but somebody told me, is that they use preamble to like high latency, right? For example, like sometimes models start with like, oh, the answer to this is this. Not because they need to answer that, because it's just like, it buys them a little bit more time until the model can generate the next token. So I certainly think that there are a lot of like techniques people can use, but it's more of a product question than like an AI questions.
Good question. One more question.
What do you think about using LLMs for evaluating other LLM-based applications? And do you think it's just a band-aid solution until we get really grounded evaluation metrics that we can use to evaluate ground truths?
I'm actually very excited about that. I do think it's like, one is the only solution right now for a lot of application in productions when there's no ground truth and we don't have the humans. However, using it requires a lot of care. So I was looking at a bunch of companies, like when they have metric with the same name, but like this metric very highly dependent on the LM as a judge itself and also the prompt. And I was looking at that, and everyone has different prompt for like different metrics. So I was talking to a PM at a pretty big company using like PM for a very popular product. And I was asking him, hey, what metrics you use? And he said like, oh, coherence, accuracy, relevance. And I'm just like, do you like, have you like, what does the prompt look like? And he was like, oh, I actually don't know what the prompts look like. So we have the situation when like one team manage the metrics and they come with the prompts, and another team using this metric, but they have no idea how these metrics are being like defined or like computed. And it has situation when like, because sometimes it's very common for people to have like typos, right? So sometimes they might change, update the metric prompts, and the downstream application developer keep using those metrics as if they were like stationary. So I do think that's like, it's very exciting, but we need a lot more rigor into using those metrics.